Good morning. Now we will discuss about sampling, samples and types of samples and samplers. Okay, these are things we will discuss. Then now tell me, what is sample? Here we are in geotechnical engineering aspects we are discussing. Therefore, sample means it is a soil sample. Then sampling means what? It is a technique of collection of soil sample and bringing from the site to the laboratory is called as sampling. Understood? Then sampler means what? Samplers are the instruments used to collect the soil samples. Then the first question arises with us is, why we need to do this sampling? Why we need to bring the soil sample to the laboratory? Obviously the answer is very easy, that we need to determine some index and engineering properties of the soil. Therefore we need to bring soil from the laboratory, from the site to the laboratory. Then why we need to follow some standard procedure? Is it a very easy task, right? We need to collect the soil sample and bring it to the laboratory. No, it is not that easy task, because here the soil samples, when you collect from the site to the laboratory, then you need to take care of few things. The soil should not get disturbed, the water content should not be evaporated, and the soil which you are collecting, the same thing you need to bring it to the laboratory without disturbing them. Then you need to get some index and engineering properties. Therefore, sampling is very important aspect in collecting the sample. Right? Now, the answer you got for the question that why we need to do the sampling, that is to determine the soil and the rock properties. They are index properties or engineering properties. For that we need to do sampling. Then, is there any factors which we need to consider while collecting the soil sample? Yes, of course. We have some factors, we need to take care of them. The samples should be representative of the ground from which they are taken. See, you are going to particular site, and from there only you need to bring the soil sample, and the properties, the representative sample which you are bringing to the laboratory, and that soil must be from the ground where you are building the structure. Right? This is just a common sense point. And the second one is, they should be large enough to contain representative samples like fabrics, fissures and fractures. Alright, means whenever you are collecting the soil sample, don't collect a small amount of soil sample like 1 kg, 2 kg, not like that. You collect the soil sample from each and every corner of the that site. Okay, and don't skip any of the properties there. If it might be a fabric, soil fabric, and it might be a fissure type of that, fractures or boulders, rock samples, and if there is a vegetation, then you get that vegetation. So take some photographs. Okay, these are all the things you need to do and bring it to the laboratory. And the third point is that they should be taken in such a way that they have not lost fractions of the in situ soils, the compressibility disturbance as possible. Okay, means whenever you are collecting the soil sample, the third point says that as much as possible, you should not disturb the soil sample. Okay, there are some properties like index properties: liquid limit, plastic limit, sieve analysis, shrinkage limit, plasticity, consistency indices. Okay, these are all points are there. For all these points, and even specific gravity, for these points, either you bring disturbed soil sample or undisturbed soil sample, nothing, that results will not matter, that will not change. But when you are checking the compressibility parameters, like your consolidation parameters, or when you are checking the permeability parameters, or when you are checking with the strength parameters, then you have to bring undisturbed soil sample. Therefore, the third point is very important, that you need to bring undisturbed soil sample to the laboratory. That you need to take care. The first one is what? Do not miss anything which are there in the field. Here, geotechnical engineering, the soil means what? Whichever that is there on the ground, that is the soil. It might be a rock, boulders, sand and soil, silt, clay, vegetation, minerals, whatever that is available, that you need to bring to the laboratory for the investigation. Okay. Now, here's a few points are there. Soil sampling is the process of obtaining the samples of soil from the desired depth at the desired location in a natural soil deposit, with a view to assessing the engineering properties of the soil for ensuring the proper design of foundation, which is already discussed. Okay, no problem. Now, types of soil samples. Types of soil samples. Soil samples broadly we can divide into three types. The first one is a representative soil sample, the second one is a disturbed soil sample, the third one is a undisturbed soil sample. Representative soil sample means it is just a representative, means go to the field and collect the soil sample to the laboratory. Okay, we don't have any hard and fast rule that there is no technique to collect the soil sample, nothing like that. Just go there with a pickaxe and shovels and with some plastic bags and collect the soil sample. If it is a surface soil sample, just by your manually you need to collect and put in the bag and bring it to the lab. And if it is a somewhat deep, if you want to go, then use your JCB or Hitachi, then go with a bucket about 6 feet and there, and you need to get the soil sample, or which is soil which is dumped there, that also you can bring it to the laboratory. Okay, this is your representative soil sample. It will not give you a detailed information about the soil, but it will give you definitely the color of the soil and texture of the soil, that what specific gravity and sieve analysis, some basic properties it will give. Understood? This is called as a representative soil sample. Then the second one is a disturbed soil sample. Disturbed soil sample, the representative soil sample is also a disturbed soil sample, but in particular, even if you go deeper and deeper, there you can get some soil that is a disturbed soil sample. Okay, disturbed means what? The water content may be evaporated from site to the laboratory when you are traveling, or sometimes the texture or some compactedness, intactness may be altered. That is your disturbance. Then undisturbed soil sample. Actually speaking, 100% undisturbed soil sample collecting is impossible. That is just an ideal thing. Okay. Therefore, undisturbed soil sample means there are some guidelines that we need to follow. There are some guidelines to manufacture the samplers, that is the instruments to collect the soil sample. Those guidelines if you are using, if you are following, then the soil samples collected by using those guidelines, then those samples are called as undisturbed soil samples. It is predicted that in undisturbed soil sample, the soil texture, water content, intactness, compactedness, compressibility parameters, these are all parameters are retained as it is there in the site and brought to the laboratory. Okay, now this is your types of samples, that is your undisturbed soil sample and disturbed. Now coming to samplers. What are samplers? As I said that samplers are instruments used to collect the soil sample. Some instruments are there. For example, your pickaxe and shovel and some pans are there. That is also the instruments used to collect the soil samples, but we will not call them as a samplers. Samplers means usually that the soil undisturbed soil sample collection. The instruments which are used to collect undisturbed soil sample, they are called as samplers. And samplers are specifically ordered and some specifications are maintained which are given by Indian standard. Those specifications are followed and according to that the samplers, the instruments are designed and manufactured. Right? Therefore, they are very specific. Now here we have two types of samplers. The first one is a thick wall samplers and second one is a thin wall samplers. The first one we will discuss about split spoon samplers. Split spoon samplers are thick wall samplers, and another one thin wall samplers, the example is Shelby tube samplers. You can see in the figure, the first one is a split spoon sampler, the wall of the sampler is very thick, and the second one is a Shelby tube samplers, then the wall is very thin. Okay, depending upon the operation of the operations, the samples are again classified into three categories. The first one is the open drive sampler, and the second one is a stationary piston sampler, and the third one is rotary samplers. Okay, the first one is a open drive samplers. Open drive samplers means the name itself, it says that you can put that soil sample and just penetrate it inside and it will go and you can collect it. Okay, this open drive samples may be a thick wall type or thin wall type, both is available in the open drive samples. Okay, and this open drive samplers, again it might be seamless, means there is no welding at all, it is a continuous cylinder, or it might be a splitted into two parts, that is your split spoon samplers. And the second one we have a stationary piston samplers. Stationary piston samplers means there will be a one cylinder with a cutting edge, and that is connected to one piston rod. Okay, the piston rod is operated at the ground surface, and the sampler which has some cutting edge, it will be sent inside the ground, and at the top, being at the top, we need to operate, and the soil is collected inside the ground. Okay, that you can see in the figure. Here, and the last one is the rotary samplers. Rotary samplers are used for stiff clays or rocks to collect the rock soil samples, because when the soil is very stiff and it is that is very hard, then the sampler will not be penetrated inside easily. Then you need to rotate the sampler and you need to send it inside. Okay, therefore we have a rotary samplers. Okay, some examples are shown in the figure. Now, sampler specifications. As I said that to manufacture, to get the undisturbed soil sample, the Indian Standard Code will give you some specifications to manufacture. Those are listed here. You can see here, this is your one sampler, and in this sampler, the top portion is called as a sampling tube and the bottom portion is called as a cutting edge. You can see here a sharp edge is there here, that is your cutting edge. Understood? Now here the diameters are written here. For a cutting edge, the inner diameter is D1 and outer diameter D2, and for the sampling tube, that is inner diameter D3 and outer diameter D4. Understood? Now sampling tube means what? Where the soil sample is collected, and cutting edge means which will help you to insert your samplers inside. Okay, that is a common sense. Then here we have some parameter, that is the area ratio. Area ratio means it is a ratio of that is a percentage ratio of the area ratio. Area ratio is the D2 square minus D1 square divided by D1 square. This area ratio is all about, explains about the cutting edge of the soil samplers. And here Indian Standard gives some specifications that for obtaining a good quality undisturbed soil sample, the area ratio should be less than or equal to 10%. Understood? You need to design your sampler such a way that the area ratio must be less than or equal to 10%. For what? For thin wall samplers. And if you are using a thick wall samplers, then it should be as high as possible, as high as 110 percentage. Okay, 110 percentage. For thick wall sampler it is. For example, your split spoon samplers, if you are designing that, then the area ratio must be as equal as 110 percentage. Understood? And if you are designing a Shelby type of Shelby tube, that is a thin wall sampler, as I said, it is a less than 10%. And the second parameter, it is your inside clearance. Some, you can see the figure here. In this one, there is some clearance it is given inside the sampler and cutting edge. Okay, that inside there is some recommendation for that should be calculated by using the formula D3 minus D1 divided by D1 into 100, and this inside clearance must be between 0.5 to 3%. Okay, then only we can say that the sampler which you are using to collect the soil sample will give you undisturbed soil sample. Understood? Then why this inside clearance is given? Because soil has some elastic expansion. Okay, when it is there inside the soil, inside the ground, it will be intacted, it is compacted by the surrounding soil. When you put a sampler and when you pick the soil sample outside, then it want to expand elastically, it want to expand a little bit, then we need to allow that soil to expand a little bit, therefore we need to give a little clearance inside the sampler. That clearance must be 0.5% to 3% as per the guidance. Understood? Now outside clearance is there. Then why this outside clearance? You can see the figure, there is again the outside also there is some clearance is given. Then why this clearance is given? To make the samplers go in deep without any much friction. Okay, therefore we need to give a little outside clearance we need to give. Sometimes what they do, that sampler is manufactured such a way that outer surface of the sampler is manufactured such a way that is very smooth. If you make like very smooth outside surface, then outside clearance may not be required. But if the sampler is somewhat your that what made up of a steel, it might be little corrosive in nature, therefore some friction will be there. That's why we need to maintain outside clearance. That formula is d2 minus d4 divided by d4 into 100, and to get the undisturbed soil sample, then normally it lies between 0 to 2%. Okay, and in all the cases that C0, that is outside clearance, should not be more than inside clearance, that we need to maintain. And we have a fourth parameter that is called as a recovery ratio. You can see here the recovery ratio means L by H into 100, where L is the length of the samples within the tube and depth of penetration of the sampling tube. How much deep it is penetrated, that is H. Then recovery ratio to get the undisturbed soil sample, it should be 96 to 98%. Okay, if you are maintaining these specifications, that is area ratio specification, inside and outside clearance specification, and recovery ratio specification, then the soil sample collected by using such samplers you will be undisturbed soil sample. Understood? Thank you. This much is enough for this class. Next class we will see method of exploration.